Morning class. How are you today? I hope you are in good shape. I hope you are healthy. Today, I'm going to present to you a topic that is about the foot of the perpendicular. It has something to do with the intersection of two perpendicular lines. So let me share to you the PowerPoint presentation. Okay, let me share this one. Right. So it is about the foot of the perpendicular. All right. So this is the definition. The foot of the perpendicular is the point of intersection of two perpendicular lines, okay, such that one is an imaginary line containing the external point and the other one is the solid line. Okay. So whenever you have the external point, just imagine that there is a line containing that external point and that imaginary line is perpendicular to the given solid line. So this is an example. So a solid line is represented by the line in red. It has a negative slope, and the external point here is 5, 4. So our target is to find this point, this green point, containing the coordinates 1.8 and 1.6. So in fractions, these coordinates are 9/5 and 8/5. So this is our target answer. So the question is how to get this foot. Okay, so this green point is what we call as the foot of the perpendicular. So if we're going to construct an imaginary line that is in color purple, it does contain the external point 5, 4, and it intersects the given solid line at this point, which is what we call as the foot of the perpendicular. So let's have a sample problem. Determine the foot of the perpendicular in the line 4x plus 3y minus 12 equals to 0 given the external point 5, 4. So this is the formula that we are going to use. Okay. So this is a different approach. It involves the use of vectors. Okay. So take note that the variable f here represents the foot of the perpendicular. The variable x represents any external point. P is any point collinear with the given line, and N is the unit normal. So I believe that unit normal is something new. It was not taught in your high school math. So this is the unit normal. So N is the unit normal. In the numerator, you can see the letter N with the braces. That is called the normal coordinates. So the content of this quantity has two coordinates. Okay, and in the denominator you can see the length or magnitude of the normal. It involves the square root of the sum of the squares of the coordinates of the of from the one presented in the numerator. This one, it has the coordinates which are used in computing the length or magnitude of the normal. Right. So the one that I presented to you, the red line, the equation for that solid line is 4x plus 3y minus 12 equals to 0. So to get the coordinates of the normal, we consider the coefficients attached to the variables x and y. So a here is equal to 4. That is the numerical coefficient attached to the variable x. And we have here b equals to 3. This coefficient is attached. Okay, this numerical coefficient is attached to the variable y. Right, so let us compute the normal vector. First, I will start with the numerator. It has the coordinates AB, 4, 3 from the given equation. And we have the denominator, that is the magnitude or length of the normal. So from the numbers derived from this equation, so we have here the sum of the squares. So 16 plus 9, that is 25. Then the square root of the number 25 is equal to 5. So to compute the unit normal, we simply divide the coordinates in the numerator by the common denominator of 5. And so the unit normal is like a point. Okay, so it has the first coordinate 4/5 and the second coordinate 3/5. That is the unit normal. This is very useful in computing the foot of the perpendicular later. So this is it, right? So we provide values of the variables. So using this formula, okay, we substitute, we replace the variables by their values. So first we evaluate, we simplify this expression, the difference between the points 5, 4, and 3, 0. So 5 minus 3, that is 2. 4 minus 0 is 4. Okay, so we have 2, 4 from this expression. The point 2, 4 from this expression, the difference point. Next, we conduct the dot product. So to simplify this expression here in the middle, we multiply the first component 2 by its corresponding first component, that is 4/5, plus the second component times the corresponding second component. So we have here 2 times 4/5 plus 4 times 3/5. So the sum is 4. Next, we apply the distributive property of multiplication. So we multiply 4 to each component of this unit normal, right? So we have here the distribution. So 4 times 4/5, we have the first component 16/5. And 4 times 3/5, we have the second component 12/5. Next, we conduct the subtraction. Okay, so we subtract 5, the first component 5 by its corresponding first component 16/5, and then we subtract 4 by its corresponding we subtract the second component 4 by its corresponding second component 12/5. Okay, from the unit from this expression. Okay, so we are doing the subtraction in a distributive manner. Then we have the comma in between. So 5 minus 16/5, that we have the first component, the first coordinate 9/5, and 4 minus 12/5, we have the second coordinate 8/5. This is now the foot of the perpendicular. Okay, this is the point where the solid line intersects with the imaginary line, and these two lines are perpendicular. Take note that the imaginary line contains that external point 5, 4. All right, so this is it. We are able to compute the foot of the perpendicular, the point of intersection, containing the coordinates, the x coordinate 9/5 and the y coordinate 8/5. So thank you for listening, class. I hope you have understood the lesson. Okay, so you can ask me after this presentation.